Welcome to our YouTube video. Today we're going to show you how to use CATIA to design the parts to assemble a radial engine. And now we're going to make the piston arm. Once you open CATIA, go to the Start tab, click Mechanical Design, open Part Design. Name that part Piston Arm. Then to enter the Sketcher window, click on the Sketcher tool and select an axis. Then we're going to create a horizontal axis, dimension that to 178 millimeters. We're then going to place one circle at the end of that axis, and that circle's diameter will be 35 millimeters. On the opposite end of that axis, another circle of 24 millimeters. Going to connect those two circles with a horizontal line, dimension that to 9 millimeters from our center axis. We're going to then mirror that horizontal line across our center axis and erase the unnecessary parts of those circles. Then I'm going to exit the Sketcher window and pad that first sketch. I'm going to mirror extent, pad it to 9 millimeters. Next, we're going to enter the Sketcher window and sketch an elongated hole Place the elongated hole somewhere on the surface. Dimension that to 5 millimeters. And then from center to center, it's going to be 130 millimeters. Then exit the Sketcher window and pocket that hole. I'm going to pocket it to 4 millimeters, and then we're going to use the mirror command again to mirror that pocket across the YZ plane and onto the other side. Again, entering the Sketcher window in the YZ plane. Going to draw a hole. We're going to use different dimension or constraint definition. We're going to make those two faces coincidence. We're going to then pad that circle, mirrored extent of 21 millimeters. Going to enter the Sketcher window once more, same YZ plane. Again, another circle. Grab the face, make another coincidence constraint. Again, pad it, this time mirrored extent to 14 millimeters. Use the hole command to drill a hole on the face of the larger diameter cylinder. Going to do it up to last, dimension it to a 24 millimeter diameter. Then use another hole command on the smaller diameter cylinder. Same thing, but this time 15 millimeters. Now we're going to use the fillet command to fillet the edges that join the circle to the shaft. Sorry, steel bar. Circles to the steel bar. I'm going to fillet those edges to 24 millimeters. And that is a completed piston arm. And now the piston head! Go to the Start tab, open Mechanical Design, Part Design. This time we're going to name the part Piston Head. And then enter the sketcher on the YZ plane. This time we're going to use a vertical axis as our reference point. This vertical axis is going to help us when we shaft the profile we're about to draw. So we can draw a rough profile of the cutaway of the piston head just with the profile tool. And then this way we can start to dimension. We're going to use just the regular dimension tool. From the top horizontal line to the bottom horizontal line is going to be 62 millimeters. And then the length of the left-hand vertical line is going to be 65 millimeters. The inner horizontal lines from the top one to the bottom one is going to be 39 millimeters. And then from the top inner horizontal to the bottom horizontal is going to be 45 millimeters. And then from the inner vertical to the axis is going to be 25 millimeters. And then from the outer vertical to the axis is going to be 46.5 millimeters. The two coincidence vertical lines in the middle will be dimensioned to 37 millimeters. Once you know the part's not going to move, we can grab the circle tool, draw a circle with a diameter of 378 millimeters. We're going to coincidence constraint that circle to that point on the left vertical line. Then we're going to finish the profile, and then we're going to erase the excess parts of the circle. Going to exit the sketcher, and then we're going to shaft that profile to 180 degrees, which will give us half of a piston head. Now to create the piston ring slots, we're going to sketch the surface of the piston. We're going to sketch a rectangle with a horizontal dimension of 4 millimeters and a vertical dimension of 3 millimeters. We're then going to put a coincidence constraint on the right vertical side of that rectangle to the right vertical side of the piston head. Then constrain the bottom horizontal line to the bottom horizontal of the piston head, and that's going to be at 45 millimeters. Now that we have that dimensioned, we're going to exit the sketch workbench, and we are going to slot. We're going to use that semicircle as a reference, slot it all the way around that piston head. And now that we have one piston ring slot, we are going to use the rectangular pattern tool. We're going to create 4 instances that are going to be 5 millimeters apart, and the reference element is going to be the sketch, the rectangle sketch, and the object is going to be the actual slot. We're going to reverse that direction so they're going up. We're going to preview it, and we're going to hit OK. And now we have all 4 piston ring slots. Now for the bottom piston ring slot, we're going to use the same process. We're going to sketch on the surface another rectangle, 4 millimeter horizontal, and a 2 millimeter vertical this time. We're going to go through the same process of constraining it to the surface. We're going to right vertical for the rectangle, right vertical for the piston head, coincidence constraint, and then a length constraint from the base of the piston head to the base of that rectangle. Go ahead and exit the sketcher workbench and slot this rectangle the same way you slotted the first one. And that gives us half of our piston head. But I'm going to use the mirror command, mirror it, so now we have a full piston head. Now we're going to use a hole command to put a hole in the outer surface of this piston head wall. Diameter of 22 millimeters. Type of hole is going to be counterbore with a 36 millimeter outer diameter and a 5 millimeter depth. And the hole is going to be up to next. Enter the sketch for the hole command, and make sure that distance, the center of the hole is 27 millimeters from the bottom edge of the cylinder head. Looks good. Preview it. Okay. There's our first hole. Make sure it's counterbored. Now we're going to use the circular pattern tool to make two instances of that same hole. And they're going to be 180 degrees apart. Hit OK. And we should have a completed cylinder head.
Here's the master rod.
Alright, here we're going to be building the master rod. We're going to start out just in Sketcher. We're not doing anything off the origin, so just get that out of the way. Everything's in millimeters, so that's standard. We're going to start out just building a circle. And basically we're sketching the head of the master rod to begin. Making construction elements, just making sure that the corner of that construction square is constrained to the center of the circle. That's going to help us build the head of the rod. Feel free at any time in here as well to pause, rewind, take full advantage of that so that you can see everything we're doing. Basically just creating a profile right here. Now here we're trimming out all of the excess material that we don't want. Alright, and now just move it around to make sure that everything's constrained properly. Pat it out. We're eventually going to mirror it, so just pat it in one direction right now. Alright, the next step is going to be to create a sketch on the edge of this, and then what we're going to end up doing is creating a plane separate from it, and then we're going to loft that, and that loft is going to create the handle of this. And the white parts we didn't want. And again, we build construction elements so that we can see everything that we want to work with and constrain it as well. It's important to pay attention to the colors here, because the green means it's fully constrained, the white means it's not fully constrained because we're adding our own constraints to this. The green we want to constrain to that construction element. Alright, here we're going to start lofting. I'm slowing it down because this part's kind of tricky. Basically you click the loft command and then you're going to click on the two sketches that you just made. Where it gets important is where the arrows are pointing, where it says closing point in section 1 and then closing point 2 in section 2. You got to make sure that those are 1 in the same place and 2 pointing in the same direction. So we had to reverse that one so it's pointing in the same direction, and now the loft looks good. We're going to do it again on the second loft. We'll make our sketch in here.